Okay, so this is how I'm going to prove the Monty Hall problem we were talking about earlier. Okay, so the premise is that there's three doors, and you can pick any one of those three doors. Once you make the pick, Monty Hall opens up one of the other doors that has one of the gag gifts. And so now you're left with the choice. Do you stay with what you got, or do you switch? I'm trying to say that if you switch, you have more of a chance of winning the good prize than the other gag gift. So here we go. So let's say, just for simplicity's sake, you always pick door number 1. Okay? Now we could do that with door number 2 or door number 3, whatever. It would always be the same. But so let's say you always pick door number 1. So here we go. We got door number 1, door number 2, door number 3. Okay. So let's say one scenario could be that in door number 1 you have the car. In door number 2 there's a goat. In door number 3 there's a goat. Now, if you were, let's say you pick door number 1, bam. Now, if you were to stay with what you got, you would win the car. If you were to switch after he showed you the goat, you would end up with the goat. Okay? Now, new scenario. Door number 1 had a goat, door number 2 had a car, door number 3 had a goat. In this scenario, again, I picked door number 1. So, if I were to stay with my original choice, I would win the goat. However, since he showed me this goat, if I were to switch, I have to switch to the car. Okay, third scenario. There was a goat, and then the car's over here. If I stay with my original choice, I win the goat. He shows me this goat, and then I switch, I win the car. So, if I stay, there's a 1 in 3 possibility that I win the car. If I switch, there's a 2 in 3 possibility that I win the car. And that's it.